I'd like to take a moment to introduce some of the capabilities of Cisco's Identity Services Engine, just in case this is something that you're not familiar with already. Cisco ICE is, I think, a very fancy AAA server. You can do a lot of the basic features for AAA directly inside of a Linux server, inside of a Windows server, without really buying anything extra. But should I enhance those capabilities and want to go a little bit extra, I'm going to get a whole lot of the following. One, visibility. I'm going to be able to look at network authentication in ways that just weren't possible with Active Directory. In terms of control, I'm going to have policies here that make sense in terms of controlling both wired, wireless, and even VPN access into the organization. This is really an appropriate place to set network control policies. While some of it can be done from Active Directory and certain things can be pushed out, you don't really have the same level of control either. So we get enhanced visibility, enhanced control, and ultimately this should aid us in our efforts to become compliant with whatever industry regulations your company has to basically adhere to. So remember that ICE is just our kind of centralized authentication point where we're going to push out policies. And then those policies will be applied to endpoints and for their role within the network. So the first thing to understand is probably Radius services. Radius is, we could say, the other side of the coin to TACX Plus. TACX Plus and Radius are both authentication methods. Radius has got this U in it, and when you see that U, I would think of users, and I would think of UDP, because Radius is UDP based, and it's also for user authentication going through a device, where TACX Plus is typically for administrators, technical people you could think of, the T for technical people, and also that T for TCP. So they're a bit different. They're both authentication mechanisms. They both handle the 3As, but they do it a bit differently. And whenever we're authenticating users like this, Radius is typically going to be a requirement. So 802.1x, MAC authentication bypass, web authentication, these are all forms of authentication. If somebody comes into the network, this is my preferred way to authenticate them. Alternatively, I might have made an exception based on MAC address, and we can also steer people into a portal and have them authenticate through a web page just as a simple fallback if they don't have .1x configured on their endpoint. So we've authenticated them. Now what? Well, we want to define what it is that they're allowed to do. We can dynamically allocate a VLAN. It's kind of cool. Your port is dynamically provisioned. It was in VLAN 10, now it's in VLAN 50. Why? Because somebody different logged in. We can also push down access control lists. This ACL will apply for like a switch. It would apply to the end user's port. So that port now has an access list that's going to drop or allow traffic based on that user's group. Then we've also got the ability to do security group ACLs. This is a concept within Cisco ICE where you construct a matrix, which is a funny name for a spreadsheet in my opinion. It's just a table, right? And this table has basically got groups across the top, let's say 1, 2, 3, 4, 5, and then groups down the side. We'll say 1, 2, 3, 4, right? And I guess 5. So here's these cells, right? And the way that we read it is we say when group 1, who's accounting, tries to access group 5, which is security operations, this should be denied. When group 1, which is accounting, tries to reach group 2, which is the internet, this should be permitted. So what you're doing is you're basically creating security groups, 1, 2, 3, 4, 5. And then when you say when group, whatever it is on the left, tries to reach whatever it is across the top, this is what's permitted. And it doesn't just have to be a blanket of yes or no. It could be permit TCP 443, deny all else. So just different things that we can leverage. Cisco also has support for posture compliance. That means we can check the endpoint and say, what operating system level are you at? What patches do you have applied? What antivirus do you have enabled? Do you have a software firewall turned on? And we can check, and if they have those things enabled, let them in. If they don't, we could reject them. And with the right licensing, you can even remediate. So our results, when we do that posture check, ideally compliant. It means you've got all the software you have, you're patched, you're ready to go. Let's get you out there. Alternatively, you could log into the network and your credentials checked out just fine. But the problem is your operating system hasn't been updated for 90 days because this is your old laptop and it's been sitting in a bag. We don't want you to get on the internet with that old laptop, with those old virus definitions, with that old browser, with those old Java vulnerabilities. So we see that your posture is not great. Because it's not great, we could force you into remediation. We could put you in a specific VLAN that just has a Windows update server. Maybe it has some other patches available. And the idea is that you'd apply all these patches, and then once you're up to date, we can reapply for access. This can result in COA, change of authorization. Basically, the ICE in this case would reach out to that switch and say, hey, things have changed. Update this user session, apply this new access list, and grant them greater freedom. Really pretty cool. Another neat feature of ICE is the ability to perform profiling. If you have done much on the offensive side, you know this is passive reconnaissance. We're going to be looking at network traffic, and we're going to try to determine what we can without maybe having a whole lot of information. So looking at things like HTTP requests, looking at DNS requests, looking at information even inside of a DHCP request, we can start to determine who's on the wire. Now there's also passive OS fingerprinting happening, looking at things like TCP sequence numbers, looking at window size, looking at things like your initial TTL that you put in your first packet. And by looking at all this detail, we can kind of figure out, aha, that's a Windows host, that's a Linux device, that's an iPad, that's Android. And based on profiling or discovery of the type of devices, we can apply different rules. So maybe there's things that mobile devices should do that laptops should not do. Maybe there's things that are appropriate for Android but not for iPhone. So we can define those based on the profile of the entity. Another neat thing is device onboarding. Let's say that we've got a larger organization and we've got different levels of access based on whether or not you're on a corporate issued device or a BYOD, a personal device. One of the things that we can allow for is called self-registration. So let's say you're out on your lunch break, you stopped by the mall, you picked up maybe the new iPad, you took it in and you join it to the network, and we go, well, wait a minute, what's that device? We haven't seen that before. But if you like, we can have a self-registration portal where your users can, using valid credentials, register their own personal devices on your network. You can have different policies for registered versus unregistered devices. And that's really nice because it allows us to grant valid users with valid devices more capabilities inside of our environment. We also have support for guest management. We can support hotspots, self-registration, as well as sponsored access. Sponsored access is where you have sometimes called the lobby ambassador, basically like a receptionist that's out front, and they have the rights to create temporary accounts for users when they come in. Sometimes I see offices where they've got a list of credentials that are basically just throwaway. They're printed each day on demand, and they'll be tossed out at the end of the day. Just realize that we've got mechanisms here to facilitate guest management in your organization if you should need it.